of logic representation, the technical documents have a quite different logical structure. So this is supposed to 3 documents in this stack. And the beautiful thing is, of these technical documents, while any invention has a different structure from another invention, the basic structure behind all of them is the same. But this logical structure is completely different from the legal structure that you see over here. And at the user interface, you must be able to see all this. You must be able to swap the information and to move from an item here to this item, and from this item to this item, and from this item to this item. Okay, and up here, that is a brain representation. That is where we model our brain to the best of our knowledge. Yeah, we implement everything that we understand about the interrelations that are what the many arrows are supposed to show. So you can go from this part of information to this part and then move over here. And from here, what is it? Is it my fault? And then move over from this part to this part. Okay, and this is our model that we have of the integration. I cannot go into details. If we look into the prototype, we can go into more details. Bleib doch mal gleich hier. Einfach die nächste Seite.
Noch tiefer, ne?
Ja, natürlich. Auf den Anfang der nächsten Seite. Okay. Yeah. Now the question is, what are we supposed to do with this information? You're supposed to do exactly that, what any lawyer and any court does. Namely, analyze the information as required by law. And in this case, we took 35 USC, and that is section 112, which deals with identifying the elements of your invention. This is 35 USC section 101, which deals with the eligibility. That is that big issue that we are having right now. And here, this is 102 and 103, which deals with novelty and obviousness. And what got to be checked by this information? That are the concerns that are implemented by these 4 sections. Laws don't exist because of somebody's dream, but there are concerns, there are social concerns encoded by the law. You know, the patent system should inspire creativity and inventivity so that the whole society can increase their wealth. Okay, now if you look into this question of what concerns are encoded by substantive patent law. So this is substantive patent law. Substantive patent law doesn't have more than these 4 paragraphs, which is amazing because alone in the United States is by far more than 5 billion per year, which are moved by these 4 paragraphs, period. The rest of the patent law is, yeah, interesting. But if you fail here, you're lost. And the investor would own, look, 90% of his decision-making would be based on these 4 paragraphs. You know, research is very expensive. Developing a drug costs a blockbuster costs more than $1 billion. So all the research, including military research, human life science research, goes into the area of hundreds of billions per year. Controlled by 4 paragraphs. That is why I think it makes sense to try to understand the whole thing. And there is nobody who understands it today, period. Our highest courts, these judges are smart, no question. But there is no way to understand a good deal of the problems just because you are smart. No way. You need help. It's a little bit the difference between an architect and a construction office. The architects originally managed to build beautiful domes. Beautiful. But they never would be possible to build 10,000 buildings like we have them here. Absolutely impossible, because these are steel constructions and you need differential equation systems and integral and all that stuff, all that mathematics. Otherwise, these systems would collapse. And exactly this is happening now in this knowledge area. That the judges and the lawyers will remain there, no question, but a branch splits off and they will do that work that in the construction area is done by construction offices.
Next one.
Okay, so this is the structure of the test. And if you see dashed lines and bold lines, then that explains what is practiced. The bold lines is what is practiced today, and where any judge and any patent lawyer thinks this is enough. And this is completely nonsense. You have the dashed lines, and if you don't check the dashed lines, the whole thing may collapse any time. Then all your rationale, all your argument chains are lousy, are not trustworthy. If you want to arrive at trustworthy argument chains, then you need these additional dashed lines also. Okay, now, the question is, what you have understood so far, that is you have understood the problem. The question is, can you operatively deal with the problem? Or is it now smart knowledge, where you can talk about with a glass beer in your hand, but nothing else, and feel fine because you know.
Is it necessary?
Could you please stop that nonsense? Or is it outside? Pardon me?
Where's it coming from?
Okay. So let me go to the next
slide.
Next slide, and that is where you have no chance to understand what I'm talking about, but intuitively you probably can grasp it. It's completely frustrating, and for a legal person, that this world is so complex. None of these judges, none of these lawyers has ever understood that the world is so complex as this algorithm. This is called FSTP test. It's a very smart test. It translates the logic that you just have seen into an algorithm so that you can run a finite algorithm. You can run a computer through it. And today the computers are so powerful that it works. 10 years ago, 20 years ago, it wouldn't have made any sense because the computing power was not there to run such algorithms. Today it makes sense, and it develops all the tests. And the test stands for an argument chain. An argument chain is nothing else but an assumption, and you test where the other party is agreeing. And the challenger comes in and says, no, 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 I have something which is wrong. So it's an argument is nothing but a series of tests that you run. And this algorithm can identify all the tests you can think of. Remember, we are dealing with a finite problem. So there is a finite number of algorithms. It may be 10,000, maybe 100,000. But it's a finite problem. And no lawyer can identify anything more. By the way, what a lawyer would be able to identify of this would be 5% or 10%. And the rest of them, decisions are made, and they got to be accepted, or Supreme Courts say yes or no, but it's not rational. It's a good deal of tossing the dice and see what happens. Okay, so this is, we call that text FSTP text. FSTP stands for facts, screening, transforming, and presentation. The whole business in knowledge representation is seeking for facts, identifying facts, transforming them appropriately, recognizing them, analyzing them, transforming them, and presenting them. That's why we have that name, FSTP test. Okay, and what we want to get working until the end of this year, that this should be a system where we have a couple of external customers working with it and get feedback. So this is the short-term objective. Now, what is the remaining part of the story? I was talking about the Turing test, and the Turing test in the future would be run by means of a person talking to a computer and the computer talking to him. Do you still remember Odyssey 2000? Back in the 70s, beautiful film by Stanley Kubrick, I guess. There was the astronaut and his computer. They are good friends, and by they get chance to see each other. That will not happen here. But in any case, how can we translate these 10,000 tests or 100,000 tests into argument chains? The simple way would be to do it the way you know it from the airports, where all the announcements come from an automaton. Somebody types it in, and you can use exactly the same technique here with one exception. And if you please go to the next.
Mm-hmm.
The yellow thing, there's something wrong here. Typo. I changed that one part and I forgot to change that yellow part. Okay, so what you see here, that is what we call FSTPDS, the data structure. The data structure comprising all the tests, all the information, all the tests, all that in a technical form, in a mathematical form. Nobody understands this computer. So what we see here, it's 3 times the same story. Up here is a user, and let's have a look into this structure. This structure has a bottom module. The bottom module would access that mathematical representation or computer representation of your test. And we have 3 different, because you can present the same test this way or this way or this way. So this is supposed to identify that they all access the same. AST stands for arguable subtest. An arguable subtest is a piece of an argument chain, which makes sense. Okay, so they all access the same AST, and they have a low-end module which accesses the computer representation. It has a high-end module which contains the audio representation and visual representation, and the middle module which represents the control information. And during calibration, you have to set up that structure. And to some degree, you would change only for one argument chain, only the acoustic representation. Maybe that you have different languages, or that you want to have a firm tone and the polite tone. It's up to you how you would structure the thing. So calibration would be quite some work, which is good for India. India is looking for new technology systems. Here they come. Yeah, okay, and the user is sitting up there, and he would play with the whole thing. And let me do one little step more. Gehst mal zum nächsten noch.
Bitte?
Gehst mal zum nächsten. And this is an outline of the possible steps of developing the whole thing. I don't want to go into all the details, but you see the final step would be HAL. And HAL is from Odyssey 2000, the computer. You know that HAL is derived from IBM. It's just a shift by one of the 3 letters, IBM. Then you arrive at HAL. Okay, and I should say it's HAL plus plus plus. It's a nice HAL, it's not the ordinary HAL. Okay, that is the end of my survey about the system on which we are working. Thank you very much.